All right, so this problem is one of the problems in my problem set. So essentially, we have this functional, which is a functional of three functions, as you can see. It's integral here, and this is what the functional is defined to be. So, and what we want to find is we want to find the um, functional of x, y, or the differential equation, sorry, that describes the that describes this system. So this is a system from general relativity. All right, so here I just expanded out this sum. All right, and then all right, and I just simplified it again right here. All right, so after that, then here's the Euler equation, which so first I just took the partial derivative of some y sub I for either y equals 1, 2, or 3. And this is like what I got here. It's kind of long, but not as long as it's about to get. All right, and so then I took where is it? I took the partial derivative of our functional with respect to y sub I prime, which is the derivative with respect to x of some y sub I. And again, I have this right here, which looks nice and clean, but then now we need to take the derivative with respect to x, which is not very nice. So yeah, this is pretty long, as you can see. All right, and so then combining everything together, I get this long thing here, across there, which actually does nicely simplify with some nice symbols into this final expression. So in other words, 0 must be equal to all these. So just to explain what some of these mean, the sigma here, it means the sum from k equals 1 to 3. So basically you just, yeah, well, I'm not going to explain that actually. This G is an element of a tensor, a rank 3 tensor. So yes, and these are subscripts denoting like which kind of element of the tensor it's referring to. Here's the second derivative with respect to x of some y sub k. And we have a first derivative here squared multiplied by this term inside here, which are partial derivatives of some elements of the tensor with respect to different y's. And we have this last thing here, well, these last two terms. Here we have another sum inside of the larger sum. So this one, where I'm summing it, this is the Christopher's symbol, this gamma right here. And then here's the Kronecker delta, which, well, I have a Kronecker delta of 0 and the Kronecker delta of some other two things, so which is basically just makes it so that it's equal to 1 if these if this j and k are the same, and if they're different, then actually no, never mind. It outputs a 1 if they are different, but it outputs 0 if they're the same. So, and then here's the partial derivative of the potential energy with respect to our given y. So yeah, this is a very, I don't know, pretty cool problem, I think. Yeah, and I just solved it. All right.